All right, guys, so before we get started on today's lesson, are there any questions over any of the assignments thus far? Any questions over anything we've covered so far? All right, guys, so what we're doing today is factoring. So we've done factoring before. We've factored quadratics, and we've done a lot with factoring quadratics, different types of quadratics, and we've done that before. But what we're looking at today is factoring these higher degree polynomial functions. Now the first one we're looking at is x cubed minus 4x squared minus 5x. This is the first one we're going to factor. And whenever we factor these here, the first thing we want to look for is a greatest common factor. Is there something in common with all three terms? X. And we can start off by factoring it out. So we factored x out of x cubed, we get x squared minus 4x minus 5. Now, x squared minus 4x minus 5 is something we factored before. We've done this before. So we'd have x, then we'd have our two sets of parentheses with three spaces. Now, normally we would look for a greatest common factor first, but we already did that. So that takes us to our two sets of parentheses with three spaces. Then we look at the sign of the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. One's positive, one is negative. Now we look at the factors of the first and third term. Well, the factors of x squared are x and x. 1 and 5. Which one would be positive and which one would be negative? 1 would be positive and 5 would be negative, and we can check this to make sure. X times negative 5 is negative 5x. 1 times x is plus x, which gives us a negative 4x. And that's it. So that's not anything different than we've done before. It's just now the greatest common factor has variables instead of just being numbers. Questions on this here? Let's look at the next one. 3y to the fifth minus 48y cubed. Is there a greatest common factor between these two terms? Anything else? We good? Yes. So when we look at B, the first thing we'll need to do is pull out y to the third. So we can pull it out. Is there anything else in common between 3y to the fifth and 48y to the third? Wait. 3. 3 is a factor in both. Now, one way you can tell if a number is divisible by 3 is if the sum of its digits is divisible by 3. So with 48, 4 plus 8 is 12. 12 is divisible by 3, so 48 is as well. And if we factor 3y to the third out of 3y to the fifth, we're left with y squared minus because y to the third factored out completely. And if anything factors out actually completely, everything factors out, it's just 1. So we have this here, 3y to the third times y squared minus 16. Now, y squared minus 16 should be familiar. It's one of the ones that we like to factor a little bit more than the rest because it is a difference of perfect squares, which follows a squared minus b squared is equal to a plus b times a minus b. It's our difference of perfect squares. So we can do our plus and minus, and a in this case would be just y, because y times y would give us our y squared, and our value of b would be because 4 times 4 is That's it. Questions on this here? So let's look at C. So this one here, we have 5z to the fourth plus 30z cubed plus 45z squared. What is the greatest common factor between these three terms? Exactly, 5z squared. And luckily with variables, whenever we look for greatest common factor with those, we see which one has the smallest exponent, because that would be the smallest amount that we can pull out, or the biggest amount we can pull out. So if I factor 5z squared out of 5z to the fourth, well, 5 divided by 5 is 1. And if we take 2 z's out of z to the fourth, we're left with z squared. Now for the middle term, 30 divided by 5 is plus 6. And then if we take 2 z's away from z to the third, we're just left with 1. 45 divided by 5 is plus 9, because if we take 2 z's away from z squared, we don't have any left. It simplifies to just 9 times 1, which would just be 9. Now that we've taken out the greatest common factor, we have 2 sets of parentheses with 3 spaces. Because after we set this up, because we know that we'll have 3 things in each spot, 2 terms and a sign for both, I look at the sign of the third term. If the third term is positive, the signs are the same, and they match the sign of the middle term. So here would be plus and plus. If the third term is negative, our signs are opposite. So now we look at the factors of z squared and 9. And yeah, 9 is 1 and 9, or 3 and 3. And z squared is just z and z. That's this would be a perfect square trinomial, but it's not the difference of perfect squares. Because we could rewrite this as 5z squared times z plus 3 squared. Or we can leave it as this here. Questions on any of this here? We'll look at one more. So we'll look at B, 5y to the 6th minus 124y to the 4th. Because I feel like at this point, we're pretty comfortable with this here. The only real difference is that we're factoring out variables, unlike the last ones. So if we look at this here, what's the greatest common factor? 5y to the 4th. And what that leaves us inside the parentheses is minus 25. Well, y squared minus 25 is a difference of perfect squares, yes? We have 2 sets of parentheses. Our signs would be opposite. Then we would have y and y and 5 and 5. Because the difference of perfect squares is kind of nice to factor. It works out very nicely. Any questions on any of these here? Okay. I think we feel pretty comfortable with those, so we'll start looking at these here. These two here are some new factors, because we haven't dealt with these before. Because when we're talking about quadratics, well, quadratics were a degree 2, yes? We wouldn't have talked about these, because both of these are degree 3. Okay. So, now there's a few things that are nice about these here, that are kind of work out nicely, as nicely as the difference of perfect squares. And there's a few things. One is whenever we have 2 cubes, 2 numbers or 2 terms that can multiply by themselves 3 times, so we have perfect cubes, we end up with one of these 2 setups. Now the first parentheses is going to have an a and b, whatever it is, by themselves. And if we look at the second one here, we start off with a squared, then we have a to the first, and they don't include it, but the last one is really a to the 0 times b squared. Well, anything to the 0 power is what? Almost 1. Anything to the 0 power is 1. So we don't include it because it's really saying a to the 0 times b squared, just 1 times b squared. But if you notice, the exponents are going 2, 1, 0 for the first term. Interestingly enough, the second term here is actually b to the 0, which is just 1. We don't write it. But then we have b to the first and then b squared. So the first term is going 2, 1, 0. The second term is going 0, 1, 2. And it'll work out that way every single time, which is really kind of nice. And it works with both of these here. And if you notice something else, that the signs actually have a unique pattern to them. However, the process of the sign still holds true because it's going to be the same, opposite, always end on a positive note. And even if we look at minus, same, opposite, always end on a positive note. Because that still holds true for any of the sum or difference of two cubes. The signs are going to be the same, opposite, always end on a positive note. So when we look at this first one here, one thing we can do is see if it is a difference of perfect cubes. And the way we can do that is by taking the cubed root of x to the third and taking the cubed root of 125, taking the cubed root of both. Now, unfortunately, I can't take the cubed root of x to the third in the calculator because, again, we need a value for x. But if the exponent and the root are the same, they cancel each other out. So we just get x. Now we need to see if I can take the cubed root of 125. Yeah, so in the calculator, the graphing calculator, we can go math here, 125, enter, and it's 5. So we can. So what that tells us, this is 5, that this here is the difference of two cubes. So to set this up, now that we have that, 3, 1, 2, 3, 4, 5. I call this, or kind of nicknamed this, the tractor trailer. Because if you think of a tractor trailer, the rig and the trailer, it's kind of what I think of. But we'll have 3 and 5. Because in the first one, we'll have 2 terms and a sign. The second one, we're going to have 3 terms and 2 signs. Now, they do throw this on the ACT, which y'all do have tomorrow. But again, even with these here, I would be looking at the signs, because again, they give you multiple choice, which is nice. Now, if we look at the signs for this here, so what did we start out with? It's a minus, yes? Same, opposite, always end on a positive note. So for the signs to be the same, our first one is minus. Then we have plus and plus. Same, opposite, always end on a positive note. And even, especially on the ACT for this one here, that would have eliminated problems. That would have eliminated answer choices, just based off the signs. Okay. Now, once we took the cubed root, these two here, x and 5, are our a and b. That's our a and b value. So in the first one, we have what? X minus 5. And I can tell you on the ACT, that already eliminated other choices, because there's probably going to be 1 or 2 that have 5 minus x. And if you're lucky, that pretty much took out everything except for the right answer. Now, when we look at the other one, these 3 spaces, we'll start with a, x. So the first one, we're going to have that term squared, which for us here, x squared really doesn't change anything with parentheses or out. It's just going to be x squared. The middle term is going to be x to the first, or just x. And the last one is x to the 0, which is just 1. We don't have to write it down. Now for our b, 5. In the first one here, it's going to be 5 to the, which is just 1, so we don't put it in. The middle one will have 5 to the first. And the last one is 5 to the second. Any questions on how we got to this point here? Now we just need to simplify. So our first one here is going to be just x minus 5. Here we'll have x squared plus 5 times x, or x times 5 is 5x, plus 5 squared is 25. And that's it. These are actually quite nice. Once you see the pattern and know how the pattern works, these are actually quite nice and easy to factor. Now, one of the things I will tell you is that this here, when we have this difference or sum of perfect cubes, it will have one real answer and two complex every time. The real answer will come from this first parenthesis here. The quadratic part of this will never be factorable, well, without real terms. Technically we can get complex factors, but the second part will always have complex solutions. The second part will always have complex solutions to any of these here. Questions on this here? Let's look at the next one. X cubed minus 64. X cubed minus 64. Can we take the cubed root of x cubed? Yes, it would be x. Now we need to take the cubed root of 64. Is 4. Cubed root of 64 is 4. Small and big. Parentheses with 3, parentheses with 5. First thing we need to do is find the sign. So we're talking about a difference. So same would be negative. Opposite would be positive and positive. I will tell you this, with any of these here, we will have 2 pluses and 1 minus. It will always be 2 and 1. There will never be a time where it's 3 pluses or 3 minuses. It's always going to be 2 and 1. Now our A term in this case is x, because A is always going to come first. So we'd have x. Our B term is 4. So our first parenthesis is going to be just x minus 4. And the bigger one, we have a squared, so it's going to be x squared. Then we would have x to the first, and the last one would be x to the 0, which is just 1. Our b, well, the one with x squared would be b to the 0. In the middle, we would have b to the first, so 4 to the first. And lastly, we will have 4 squared, b squared. And if we simplify this here, we have x minus 4 times x squared plus 4x plus 16. Questions on any of this here so far? Are you ready for the next one? All right, we want to factor 16s to the 5th plus 54s squared. Of? Because there's the greatest common factor of 2x squared, yes? Now, if we looked at this originally, so 16, now if I tried to take, or if we take the cubed root of 16, let's see what we get. We get a decimal. So what it's telling us is we can't actually take the cubed root of 16. So if this is going to be the sum or difference of perfect squares, or here a sum of perfect squares, hopefully there's a greatest common factor we can pull out. So if we pull 2 out of both of these here, 16 divided by 2 is 8. Now, s to the 5th, I can't take the cubed root of it. Because the next s value that we could take is 6. Because for us to take a cubed root, it has to be divisible by 3. But if we factor 2 of them out, it takes it from s to the 5th to s to the 3rd. Okay, we can take the cubed root of s to the 3rd. plus. Well, if we took the cubed root of 54, it would not come out to a whole number. But if I divide 54 by 2, we get 27, and the s squared factors out completely. Now, at this point here, we can take the cubed root of 8s cubed, and we can take the cubed root of 27. Well, we've already seen the cubed root of 8. It is 2, and the cubed root of s cubed is s. Now the question is, what's the cubed root of 27? It's going to be 3. 3 times 3 is 9. 9 times 3 is 27. Any questions on how we found any of this here? So we'll still need the 2s squared. So we'll have our set of parentheses with 3 spaces and the set of parentheses with 5. Now our signs. Same, opposite, always ended on a positive note. So since we start out with our sign that we're trying to factor as plus, same would be plus. Opposite would be always ended on a positive note. A in our case is what? So the first one is going to have 2s. Our B in this case is 3. So the first set of parentheses is going to be 2s plus 3. Now going across the bigger one here, a squared is going to be 2s squared. Then we'll have 2s to the first, and lastly 2s to the 0, which is just 1. Our b's, so in the first spot we would technically have 3 to the 0, b to the 0, which we don't have to write in. The middle one would be 3 to the first, and the last one would be 3 squared. Questions on any of this here? And if we simplify this down, we would have 2s squared times 2s plus 3. Now for the first one, because all of the rest of that so far has just been simplified as it was, 2s squared, 2 squared is, and s squared is s squared, minus 2 plus times 3, 2 times 3 is 6, and we have s plus 3. 3 squared is 9. And that would be it there. Any other questions on any of this here? We're going to look at one more because I feel like we need to get one more, especially that had a greatest common factor to begin with. But are there any other questions on this here before we look at the next one? So the next one we're looking at is negative 16x to the 5th minus 250x squared. And it is going to be negative 2x squared. Because negative 16 divided by negative 2 is x to the 3rd. Plus, because 250 divided by negative 250 divided by negative 2, negative and negative makes a plus. 250 divided by 2 is 125. At this point here, we've already taken the cubed root of 8x to the 3rd. Because cubed root of 8 is 2, and the cubed root of x to the 3rd is x. And the cubed root of 125 is 5. So we did that there partially to make sure that it is a difference of perfect cubes, and also to get the values of a and b. Now our signs are going to be the same, opposite, always end on a positive note. So we're talking about a sum, so the same would be plus. Opposite would be minus. Always end on a positive note would be plus. So the value of A is 2x, so it's going to go in front. Our value of B is 5. So in our first set of parentheses, we'd have 2x plus 5. For our values of A, well, in the bigger one, we would have 2x squared. Then we'd have 2x to the first. And lastly, we would have 2x to the 0. We don't have to write it in because it would simplify to a multiplication of 1. Our values of B, well, the first one would be b to the 0, which we don't put in. In the middle, we'd have 5 to the first. And lastly, we would have 5 squared. And if we simplify this down, we would have negative 2x squared times 2x plus 5. Then 2x squared, 2 squared is 4, and we'd have x squared minus 2x times 5 is 10x, and lastly, 5 squared is 25. And we have this. Any other questions on any of these here? You feel pretty comfortable with these here? The last type of factoring that we're looking at today is factoring by grouping. And I just think of this as the greatest common factor being used multiple times. Now, the main area that we can use factoring by grouping is one is if there's going to be something in common with a lot of them, and there's an even number of terms. There has to be an even number of terms. Now, when we do this here, we're used to factoring out a greatest common factor from every single term. But there's a little trick we can do, and we can pair them up into an even number of pairs, or an even amount of pairs. So here we can do 2 and 2. And what I'm going to look first at is these two terms here. Is there a greatest common factor between z to the third and 5z squared? Z squared. And I'm going to factor it out. Because if there's something in common with all the terms that we're looking at, we can pull it out. So if I factor a z squared out of z to the third, I'm left with z. Plus, if I factor a z squared out of 5z squared, I'm left with 5. Now we can look at the next two terms, or the last two terms. Negative 4z minus 20. Is there a greatest common factor between negative 4z and negative 20? Negative 4, yes? Minus 4. If we factor a negative 4 out of negative 4z, we're left with z. If I factor a negative 4 out of negative 20, we're left with plus 5. Now that seemed a little weird to do that, but if we look at it now, is there something in common with both of those terms? Z plus 5, yes? We can factor that out. So I can factor a z plus 5 out of both terms, which would give me z plus 5. If I factor z plus 5 out of this first term, what I'm left with is, if I factor it out of the second set, I'm left with so interestingly enough, this will factor to z plus 5 times z squared minus 4. And that's it. Questions on this here? Let's look at the next one. So again, we can always group these with the first two terms and the last two terms. Now here, if we look at the first two terms, x cubed minus 2x squared, I can factor an x squared out. X squared out of x to the third is x. X squared out of negative 2x squared is negative 2. So what am I hoping I get in the parentheses over here? X minus 2. So what do I need to factor out of negative 9x plus 18 to get x minus 2? Negative 9. Because once you get one of the parentheses, you can use it to figure out what you need to factor out of the others to get there as well. Now at this point here, we could factor out an x minus 2 from both, which will leave us with x squared minus 9. Questions on any of this here? We're going to do one more. I'll let y'all pick. Do you guys want to look at 6 or 7? We can look at 7. And again, we can group these, the first two and the last two. So looking at 3y cubed plus y squared, what's our greatest common factor? Which will leave us with 3y plus what? Because when we factor a y squared out of y squared, it is 1. Anytime that something factors out completely, it's 1. What's our greatest common factor between 9y plus 3? Which will leave us with 3y plus 1. And to get at this point, we can factor out the 3y plus 1. And if I factor it out of the first term, we're just left with y squared. And if we factor it out of the second one, we're left with, and that's it. Any other questions on any of this here? And that is it.